Shashank, did you hear about this? The Chinese DoorDash just came out with a 1.6 trillion parameter model that they trained state of the art, one of the best open source models out there, 1 million context token window. And hear this, they didn't use any American made GPUs. They're a little bit hesitant or like a little bit shady about exactly what they use, but I think everybody knows it's Huawei. They used 40,000 or 50,000 Huawei GPUs, probably Huawei, that are ASICs specifically made for training, and they were able to make a state-of-the-art LLM topping a bunch of the benchmarks. Shashank, this is crazy. I feel like no one's talking about this. Let's talk about it right now. Shashank, what do you know about this?
It's nuts. When I was in China, I was using Meituan. This is the parent company that made this. It's like a DoorDash plus Yelp plus hotel booking. It's like all other Chinese apps that are super apps. They have a bunch of features, but it is essentially a delivery app. You order food, but now they decided, hey, we're gonna build a frontier model, and they just announced it. It's completely open source. It's 1.6 trillion parameters. It's an MOE, so it has 48 billion active uh, parameters per token. But yeah, I think the most interesting thing about this is how they trained it. They built it on like this large scale deployment of AI ASIC superpods. And so, like you mentioned, I think they're probably using Huawei because it's like this cold war between U.S. and China. The U.S. banned Fable a few weeks ago from being used by any non-U.S. citizens, and China's just been making amazing open source model, opening it up for free because I think they can't compete with the IP, with the sheer algorithmic progress that the US has, or maybe the funding, or maybe like it's the Nvidia's dominance. So now they have to resort to just opening everything up for free, and they've done it again. So they've released a few benchmarks, and it's up there. It's just trailing behind Claude, OpenAI, Google, but they no one has done a thorough benchmark analysis on it yet. But I did ask ChatGPT, and it's trailing just behind GLM 5.2, the other Chinese model that is currently at the top of the open source benchmarks. So this is neck and neck with the top Chinese models.
All right, so I feel like we need to kind of talk about this a little bit more, right? So this is a big deal, right? Because just like DeepSeek came out and kind of shocked the world, and we actually talked about DeepSeek long before like the stock market reflected it. But like LongCat, no one is talking about this. This is a brand new company. I mean, like the company has been around. It's like DoorDash, right? But like they are making state of the art open source models actually going, and like this is not some sort of like baby model that like somebody fine-tuned like on their like extra spare laptop or something like that. This is like serious model right here. Like they were using tens of thousands of custom made AI chips to build this. This is 1.6 trillion parameters. That is like big model, and it's like very cost competitive, and you can use it with like OpenClaw and Claude Code, and you can use it with Codex. Like this is a big deal. And like, sure, is it like the top open source? Like maybe not, but like it's competitive. So now we have one more company that just like came out of literally nowhere, right? It'd be like if like, I don't know, Waste Management or something decided to make like a top of the line, state of the art coding model. Like this is like big state of the art lab, right? So like China has so many different companies all working on like another model, right? Like we've got like Minimax in China, we've got DeepSeek, we have ZAI, and now we have the company that makes LongCat, which is Meituan. Like this is a big deal. There's like now another competitor in the race. Like the United States doesn't have as many competitors as China has right now. So I feel like more people need to talk about this, that like there are people who are not using Nvidia chips to train like close to near state of the art models that you can actually use. Like this is a big deal. This is a really big deal. Like the architecture is cool. It's important, but like what's more important out of any of this is there's a new player in the game actually like making new stuff. Big deal. Very big deal. Like the because the thing is these to make these models is incredibly capital intensive. Like
Mm.
you need to buy you need to have a lot of funding. You need to go maybe have data centers, you need custom hardware. Like not anybody could just like go and build one of these models. Like logically it's maybe not like super difficult, right? Like a lot of the like the know-how is there, but like the hard part, like one of the hardest part is getting the data and getting the actual compute to do this. So the fact that like there are multiple companies in China like that have enough data and enough compute in order to make like one more state-of-the-art model is a big deal. And that's going to put a lot of pressure on like all of the other proprietary closed source models. Cause like, yeah, we have Fable, but like Fable has been incredibly neutered. Like I've been playing with it and it is not like is not as good as I remember. Like it's still smart, right? But like there's always this thing in the back of my mind, like I'm wondering, is Fable being demoted to Opus? Because like, I'm using Fable and it's making a lot of mistakes. Like it's making a lot of mistakes. And you know, does it make less mistakes than some of the other top of the line models? Maybe, I don't know. It's hard to say, but like these Chinese models are really, really, really smart, and they'll actually do what you want. Like they're not going to like silently degrade to something else. And we have one more, and I want to stress again to everybody listening. This is a big, big deal to have one more person or like one more company actually like trying to go and then leverage the Huawei hardware, get off of like the Nvidia bandwagon and have some sovereignty with AI. So like I don't think this is reflected in the market yet. So like again, one more time, big, big deal.
Yeah, I think this reflects Jensen Huang's concerns last year when they had export controls and they prevented NVIDIA from shipping their best models to China. And he was like, you know what? You're just stifling NVIDIA because you are allowing China or you're forcing China to rely on their own infrastructure, their own chips, build their own supply chain, and then rely on their own companies. And that's what they're doing now. So it seems like based on some Reddit and X threads, they are relying on most likely relying on Huawei Ascend 910C chips. And there's some visuals and graphics about how they're doing this, but they're combining two physical dies. And we've talked about chips a couple times in the past and how combining, each of these chips only has a certain amount of compute. And what NVIDIA's latest chips are doing is just combining both chips very closely with high bandwidth interconnect. And an alternative to this is what Cerebras is doing. Just like stamp a big ass chip on the entire wafer's surface area as big as you can. Cut a square as big as you can on the entire silicon wafer, as opposed to like cutting little squares and then combining them with physical dies. But most of the industry is doing this, and Huawei, of course, is uh, not doing anything special, but they are catching up to NVIDIA, and this shows that they're able to train a frontier model with completely Chinese software, Chinese hardware, and this is super, super impressive. And freaking made by a delivery app, and it's called LongCat. So this is where the internet, this is where the world is at right now.
Yeah, LongCat has taken over the internet. But yeah, so I think that another thing to kind of note about some of these Huawei chips is, even if they aren't as good as Nvidia, right? Like if they're cheaper and you can actually get them, like, it's okay because, when you train these LLMs, it's oftentimes, like, massively parallel, right? So, you're not just using one of these chips, right? But, like, you might be using 1,000 or 10,000 or, in this case, 50,000, different chips, right? So, let's just, make some numbers up. Let's say the Huawei chips are half as good, right? Let's say they're 50% as good as the Nvidia. I think that's not the case. I think, it's probably a little bit better than half as good. But let's say it's like, 50% as good. Um, well, China has a lot of money, right? And a lot of these companies in China have a lot of money. So they could just, in theory, buy twice as many. And then now they're equal to Nvidia capability. Now, like, it's not exactly apples to apples, right? But it's like, let's say you could accomplish the same thing with like 25,000 um, Nvidia chips, but like it takes 50,000 Huawei chips to do the same thing. You could just buy 50,000 Huawei chips. Like that's like a very reasonable approach to do this. And like I think that probably should just scale. So and like if the Huawei chip is half the price or even less than half the price, let's say hypothetically the Huawei chip was 30% of the cost of the Nvidia chip because like a lot of people are going after Nvidia. Like Huawei could probably compete on pricing because Nvidia has some very healthy profit margins. Like if Huawei says like, hey, we're just gonna not have quite as healthy. We're okay with getting like 20% margins or something. Whereas Nvidia's got like their 70 or 80% profit margins. Like Huawei still can have a very healthy, profitable business and also price themselves at a fraction of what Nvidia is. And then maybe if people say like, well, hey, look, like Nvidia, this is like way too expensive. We can actually save money by twice the amount of Huawei chips and we can like optimize on that and then have completely I mean, like if for the Chinese, they're probably thinking like, well, we can have a completely self-sovereign domestic market that we don't have to rely on, any foreign companies. Like, let's just dole off of Huawei and we're gonna be able to get like almost just as good results. Yeah, sure, like maybe it's not quite as power efficient, it's a little bit slower, but you can just buy more. And like Huawei is continuing to iterate and improve, and there's going to be sort of I look at it as like within the Chinese space, there's a bit of like a virtuous cycle where you have maybe 5 to 10 different. And we don't know exactly how many there are, but um, I mean, there's like if LongCat can come out of nowhere and then make another model, there probably could easily be 10 or 20 of these Chinese manufacturers making state of the art models, potentially building in secret. And then when they're ready, they could go publish their findings, and then all of these companies can go and look at what everybody else is doing, share notes, and work on things together, right? So it's like, let's say DeepSeek makes some sort of advancement in technology where they're able to optimize Huawei's chips. Well, then like now like ZAI and Minimax and all these different companies can go and say like, hey, look, like DeepSeek did this. Let me take advantage of what they did and then iterate on that. And then we can all have better models together. Whereas like inside the US, there's like this huge kind of like, I don't know how to put this, but it's like, it's more secretive, right? So it's like, if OpenAI independently discovers how to make things better, they're not like publishing that. They're not sharing that with the world, right? So it's like every single company has to like, have their own battle scars and there's benefits to that, to like figuring out things on yourself. Like you have more like tribal knowledge, I guess. But then like that just kind of slows down progress. So it's like if your goal is to have faster progress, like you want all these companies to share the work that they did. So like together they'll go even farther. And yeah, I don't know. Like I think that like the Chinese approach is very interesting. And I think that like right now they are like a little bit worse than the American models. But like they're winning in price, and there's also more companies sharing more things. So like in the long run, I think that the open source maybe could win. We'll see.
Yeah. I kind of wanted to show you this. Have you ever looked at any of the papers that have been published by these Chinese models?
I mean, I've looked at some, but I don't know
I,
which one did you have
I,
in mind.
I looked at DeepSeek a long time ago, but this one I just wanted to show you like the LongCat paper. Look at how many authors there are in this freaking paper. There's like 100 authors visible here, another 66, like close to 200 freaking authors on this one. Another their Flash model. So apparently LongCat or Meituan, the company behind LongCat, has been making this for at least a year, maybe longer. And another close to like 200 people on this. Switch over to DeepSeek. There's like 200 plus another 100. There's like 300 people who worked on this, and it's all public. It's shared for everyone to see. And for comparison, if you want to look at the paper that started this all, the attention is all you need. There's like there's like
Was it
uh
8?
there's like 8 people on here.
4, 5,
So
6, 7, 8. Yeah, 8 people on the attention is all you need.
it
So,
shows the amount of people that are collaborating, the amount of information that's being exchanged, and completely in public. All of the research, all of the algorithmic breakthroughs that are being made here, I think is incredible for the entire research community at large, and specifically Chinese, because like you mentioned, the U.S. companies aren't sharing any of this information. They aren't publicizing any of their results. And going back to your point about Huawei versus Nvidia, I think the like 10,000 foot view here is that the whole world is compute constrained. We don't have enough chips, we don't have enough data centers, we don't have enough energy to fuel all of this demand for AI that is going on right now. And so even even if uh, we did have enough compute, the Huawei chips, I think they're still pretty good. So I asked Google's AI, how good is the Huawei Ascend 910C compared to NVIDIA's latest Blackwell? And it's roughly 50 to 60% as good for AI inference and training. So if you look at some of the specifics, it's on an older architecture, sure, it's 7 nanometer. NVIDIA is much newer on a 4 nanometer node. But if you look at cost comparison and specifically like the energy requirements. The Ascend requires like less than half as much energy compared to the NVIDIA Blackwell, and the Blackwells are like so freaking expensive. They cost like a significantly higher amount to deploy upfront, 3x more. So I think if you add all of that up, it is not that bad to use a Huawei chip, but I think the challenge is just deploying it at scale, getting people familiar with the drivers, the kernels, the all of the infrastructure that NVIDIA built with CUDA to let people train and iterate on the research side on their infrastructure. So I think that is also slowly being built up, and eventually, I wouldn't be surprised to see Huawei competing neck and neck with NVIDIA.
I think that's a really good point where, NVIDIA does have a lot of the architecture around it. So for those that don't know what CUDA is CUDA is a programming language that allows you to work with the NVIDIA GPUs directly, like allows you to kind of work directly with the hardware. Um, but like a lot of people who are programming don't actually focus on the hardware that much, right? So it's like there's actually like a lot of oftentimes like abstraction layers over the hardware, meaning like, you're not writing for the NVIDIA GPU, you are writing for like all GPUs or like all computers sort of generically. And there's like oftentimes like a program on top of that that kind of hides away the complexities and the details. And that's actually an excellent thing because um like you don't necessarily need to know all the intricacies of CUDA. Now, like if you want to get every last ounce of performance out of your hardware, like you can go and then, program in CUDA. And that's like what a lot of the folks at DeepSeek did is they were like going in and they were using an older Nvidia GPU and they were like going in and fine tuning all these little knobs. But you can say like, hey, look, let's not fine tune all these little things. Let's just buy 100,000 Huawei GPUs and we'll use like a little bit of an extraction layer over on top of it, and it'll be a little bit slower, but like we'll be able to do everything we can. And actually, since the Huawei is like a third the cost of Nvidia, like we can buy twice as many and get similar results, or we can buy like you know 2.1 or 2.2 times as much, and we actually save money and we'll actually do better than what we would have with NVIDIA, and we'll just focus our time on optimizing this abstraction layer. So, for example, so the abstraction layers that we'll use is like Google's got TensorFlow. Is that like is that what it's called? The TensorFlow?
Yeah. TensorFlow. There's Keras. There's PyTorch.
Yeah, there's PyTorch. There's TinyGrad, and all of these things, all these programs, they will work with the underlying hardware. So like most of these deep AI researchers, they're not like optimizing a little bit of hardware. They are just like, working at like one level of abstraction. So hypothetically, if China just said like, hey, like you 200 people go and then work on this like hardware optimization and try to make like work on the software, work on this abstraction layer and try to eke every little last bit of performance you can out of these Huawei GPUs, like with enough time, I think that like they're going to be very competitive. And I think that as like an aside, I think that the Asian mindset is very much more like collaborative than like the Western mindset. So like for example, like I've spent a lot of time like living in Japan, and I spent a lot of time living in America. Right? I grew up in America, but now I'm living in Japan, and in Japan, like there's kind of like a much more like a mindset of like doing things together as like a community, and like not trying to like stick out. Like you're not trying to like show off, but like you're just trying to like sort of conform to like what other people are doing. If that makes sense, right? So it's like you're not trying to be like the rock star programmer, but like you're trying to like reach consensus among all things. So like for example, when I was working at a company back in Japan, I was working at this bank, and I was working on some stuff there, and they have this process in Japan. It's called the ringi system. So like if you want to go and then get like do something. So in our case, what we wanted to do is we wanted to go and then buy some new hardware for the company. So like everybody wanted some like brand new laptops. So like nobody wanted to take like full responsibility for buying the laptop. So what you do is you go around and then everybody has their own stamp. So like it's like the ringy stamp, and then people will go and then they'll stamp this document. So let's say you have like, I don't know, 8 decision makers. Every single person will say like, I approve of this decision. And then like you'll go around, and then like if any one person says like no, then like you don't buy the laptops. And that actually happened to me. Like I wanted like some more RAM on my laptop, and then one person said like no, I don't approve of this, and nobody got the laptop. But like it's very like consensus driven. And I think that is like there's pros and cons to that, but I think that like when you can have 200 people work on a paper, like as you mentioned for LongCat, like what's cool about that is now 200 people are going to like know how this stuff works, and they're going to be able to iterate on this together. Whereas like in the attention is all you need paper, like there was only 8. So then like 8 people are now like experts on attention, whereas like in China, there's like now 200 people that are experts on attention. So you have much less of like a bus factor. Where like if you know like the bus factor is like if one person got like hit by a bus, like how much would that like affect it, right? So it's like you couldn't even fit 200 people on a bus. But like hypothetically, like if you had like I guess all this is getting really morbid, but like you had like all like 8 people like in a car, you could fit that like in like an SUV. And then like if that was in a car accident, it's like boom, all that knowledge is lost. But like I don't think there's too many buses that will hold 200 people. So it's to be a couple bus accident. It'd be a very tragic accident. Anyway, you see where like I'm kind of going with this, but like the point is like the more people that like are working on it, like the more expertise, and then like the more people that can independently make improvements and they can share together. And it's like I don't know, it's like you know that saying is like if you want to go fast, go by yourself. If you want to go far, you go together. I feel like the Chinese are like and like the Asian culture is really exemplifying that, and they're gonna go slowly but more far together. And I think that's just like really exciting. It's just like it's really cool to see like how like what like the Asian like Western like philosophies are like working on these like models together. And I don't know, it's still early, right? Because it's like right now, like the United States has like the initial lead, so like kind of like the individualistic mindset is going fast. But then like I wonder, it's like, hey, like we want to go far, go together. Like let's have 500 people all work on this, and let's see how far we can take this, and maybe they'll go like much farther together. So I don't know. I really don't know what's gonna happen, and I'm like waiting with bated breath because it's like really fun to watch this horse race, and both are both are like very viable approaches, but I just think it's kind of interesting. And I don't know. Well, we could go into history, but I think that would distract too much from this podcast.
I,
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 but
I think I think I agree with the analogy there, and I feel like the Chinese have a more communal mentality versus the more individualist mentality in the West, especially in the US. And I think that's also because there's very little IP protection. Your proprietary tech can easily be copied. They manufacture hardware for dozens of companies in the US, and they just copy the hardware that they build and white label sell it for anyone who wants it on Amazon or uh, Alibaba. And so I think there's a less of this uh, tendency to hoard IP, hoard proprietary tech, and just compete on margins, compete on services, manufacture at the lowest possible price point so that it is attractive enough for customers to buy. But moving on from this and trying to find, talking about more diversification of this bus so that we have more competition. We were going to talk about this a little bit later, but OpenAI unveiled this first custom built inference processor. So they're working with Broadcom to build a custom chip. So this is not the whole chip. As you can see, I'm sharing a picture of Sam Altman holding a big ass wafer. It's going to be sliced up into multiple little chips, and
it looks like
it's
a
going
dinner plate.
and it is about the size of a dinner plate, which is what these spools of silicon are. So this is I'm showing a cross section of a spool of silicon. It's a big ass pipe of silicon that is sliced into chips, into wafers or dinner plates, and then you have these lithography machines from ASML etch a bunch of different designs on them. So they've partnered with Broadcom to build their own custom chip. So this is like the amplification of AI labs. Each AI lab is trying to build their own hardware to optimize for their own models because um, some of these spends are getting insane. We heard a bunch of news last month about companies spending $500 million a month on inference on like Anthropic API or OpenAI's API, and the spend is getting ridiculously high that it is worth your while to build your own chip from scratch to optimize for the inference that you have at scale. Because like OpenAI has close to a billion users, Google has close to a billion users. Anthropic is much smaller, but their inference is a lot more expensive, so it costs a lot. And they're all running on the same hardware. They're all running on whatever hardware they can find because, like, we're all supply constrained. We don't have enough hardware to begin with. So that's another issue. But even in this hypothetical world where we did have enough hardware, each chip, each model works differently on a different chip. And actually, Semi-Analysis, which is a great company that focuses on semiconductors and analyzes the entire industry, has been analyzing um, inference capability for different models across different chips. This is one example. They their the thesis for this website that they made was, hey, every inference provider, every chip is different. Every model runs differently on different chips. And so the same model at a specific snapshot in time is going to have some performance on Nvidia chips, is going to have some performance on Google's chips and Cerebrus chips and AMD chips. So we need like a live benchmark of the best that a model can perform on the best chip for that model. Because, the model size is different. They have different sparsities. They have, some MOEs. They have some dense models, smaller models. Sometimes you can fit many of them on a chip. Sometimes you need multiple chips to fit just a single large trillion parameter model. So,
Okay.
um,
So like just to interrupt, I just for the audio listeners, Shashank is sharing his screen and he's showing a graph from some analysis. So basically what inference is the ability to use the model. So in AI, there's two different things that you can use there do. There's training and there's inference. So training is making a brand new model, right? So it's like LongCat, they trained on a bunch of data. They used 50,000 GPUs, and they made a brand new 1.6 trillion parameter model. Inference is like, okay, now that the model is already made, how do we actually use it, right? So it's like, we're using now this like big multi-terabyte model. Like we want to go and then use it on the GPU, and then that is much less compute constrained. So like for inference, that might fit on like maybe not 50,000 GPUs, but it might be like one or two, or maybe like three or four, right? But it's not like 50,000, it's like one. So like it's like you might even be able to put some of these smaller models on your computer. So that is inference. So she's showing about like how each of these GPUs compare for using it versus training a new one. So sorry for interrupting. Go back to what you were saying.
all good. So I think the world right now is spending way more on inference than on training because the amount of users have shot up. The agentic use has shot up. The asynchronous loops that people are engineering has shot up. And so people don't even need to prompt these models anymore. They have agents prompting themselves in a loop endlessly until it just keeps making your product magically better. Mark has some of those loops. Maybe you can share some of those insights later. But I think the key takeaway here is that inference spend is going up. It makes more sense to build your own hardware to optimize for your specific model. And that's what OpenAI is doing, and kudos to them. I think they might need this. We've seen a lot of reports about how they're they're not doing as well as some of their competitors. Anthropic has soared past OpenAI in terms of valuation, in terms of annual revenue. OpenAI is hemorrhaging money, losing a lot. And so this will be, I think, something that will help their bottom line as well.
I hope that it will help the bottom line because I don't know, making
Okay.
custom ASICs is also very expensive, right? Because now you can't just buy hardware off the shelf, but like you have to continue to support your own hardware from now potentially into the future. Which like in theory might save you money, maybe, because like you can cut into like the large profit margins from Nvidia or whatever, but um like, I don't know, and I think it's like time will tell. But like AMD chips are a lot cheaper than Nvidia. Like Huawei chips are a lot cheaper than Nvidia. And like, yeah, Nvidia has a lot of like CUDA ecosystem and has like a lot of developer mind share. But like, I don't know. Like, part of me would wonder, would it make sense to have a small team of people try to just like optimize an AMD chip and or a Huawei chip and just like use that versus like trying to make some sort of custom hardware?
I mean, have you seen some of these companies, the stock valuations of some of these companies shoot up in the last year? Hardware is sexy right now. Software is no longer sexy. All the SaaS companies are like down 90%. Adobe is down 90%. Salesforce is down. Hardware is sexy. Intel, the once dead fabricator, is now back up like 500% or something in the last year. Hardware is really sexy. We don't have enough hardware manufacturers. I think it makes sense for them to pay to build their own hardware at this point.
I mean, maybe. But like, I think that we need to stress that like you can get a lot of gains from software as well. So I remember when I was in computer science, like 10 years ago, it's been a while. So in my class, my teacher said like, "Hey, let's imagine we had like the best top of the line processor, and it could process things like 10x more efficiently than we can do today. And then it used like a sorting algorithm. It's like, how fast can we sort it? And it's like, let's just throw more hardware at this problem. It's like, well, but if we optimized it, we could use this software gain and we could get like 10,000x improvement, and then we need a lot less hardware. So it's like, to me, I feel like you use hardware when like you can't figure out how to like optimize your software. Because like oftentimes there's a lot of gains that you can get through software. And sometimes like you've optimized everything you possibly can. But like right now, I'm gonna say it that I think that like training LLMs and LLM inference is actually pretty inefficient, right? Like there's a lot of things where like, yeah, they're like parallelizing it, but like um you can't always parallelize everything. And I am convinced, and I don't know how, but I would be willing to bet that if somebody thought like really, really, really hard, there might be able to be a lot of software improvements where like you'd be able to eke much more ability out of these models that like, I mean, so think about this, right? Like the existence proof is like your human brain exists, right? Like the human brain is like about as powerful as like, I don't know, like $1 million supercomputer, or even like more than $1 million supercomputer. Like, the human brain, some say it's
Way
like,
more, way more. Million is not that big right now. Inflation.
well, yeah, inflation, right? So it's like, um like a human brain is like maybe like some people say like it's like a 10 petaflops of compute. Some people say it's like an exaflop of compute, right? Like 10 petaflops might cost you like, I don't know, like $20,000 to $100,000. An exaflop might cost you $1 billion, right? And these are running on huge amounts of like servers and energy, and you need like all this like uh compute, right? But like the human brain um runs for like almost no power. Like it can be ran on like a Big Mac.
Yeah, I mean, we do require a lot of power, but not at the scale of these models.
Look, I mean, like, it's not that much power. Like, I could eat like a bowl of rice and get my power needs for the day. And like, sure, it's like a chemical process, but like the thing is that the fact that the human brain exists and it uses a lot less power than these data centers. Like, imagine how much power that you take, because like Elon's data center.
To be fair, my brain is only serving one user. These data centers are serving hundreds of millions of users. Just to set a comparison.
I mean, sure, but like if I wanted to run GLM 5.2, right? Like locally, that might cost me like $500,000 worth of compute to run it well for like inference, right? Because it's like, I would need
It's
like
big.
a bunch of RAM, like I need expensive, like you could probably get the price down a little bit, like 500,000, maybe if you're really, really careful about it, you could get the price down to like 100K or maybe 50K if like you really like were careful about it. But like the point is that like the human brain is tiny and it doesn't need that much power. And it's like fast and it runs multiple parallel and it's smarter than like a lot of these models, right? Um, and the fact that the human brain exists means that there is room for improvement on the software side and maybe also the hardware side. So I think that like in the future, when we figure out some of these algorithmic improvements, we might be able to get like our software and hardware, if we get the right architecture, we might be able to get like 1,000, 10,000x improvements. So then like we might have like way more hardware than we actually need. And like, do I know the algorithm? No, not exactly. I don't think anybody does. And I think if I do know the algorithm, I'd probably be a lot richer than I am today. But um, yeah, I think that the algorithm is out there, and like I think it could be something really simple. Like it could be like, oh, you just like divide by like 3 here, and then like you like flip this bit here, and then boom, now you got like 100,000x improvement. Like that is possible. That is very possible. It could be like a 2-line change in the code. And like I think that everybody is like, I think it's very easy to say like, look, we have these attentions uh, algorithms, and we know that they scale up. And it's like a very easy thing to say, like, oh, just buy more hardware, put more money into this, and like you can get smarter. But I think that's like a very dumb way to think about this. Like, I mean, yeah, it works. It's true. A lot of smart people are like just throwing money at this because like it's like a proven strategy that works. But like, yeah, I think if we're a little bit creative here, we might be able to get the cost down dramatically. Like, I think that 10,000x improvement is here or like is possible, and it's possible in software. I don't know how it's done. I wish I knew, but I bet if someone like thought hard enough about it, they could probably figure out how to train a model for 10,000 times cheaper than today. Now, I'm going on a limb. I think that's possible.
So just to share some numbers, I don't know about 10,000, but I think at least 2x would be feasible because right now, and maybe some hardware folks can chime in and explain why this is impossible. But right now, the GPU utilization is roughly like 45 to 50% when training models. And this is because of a lot of reasons. Peak performance is bounded by the GPU's theoretical teraflops. We have issues when you train sparse models. We also have a memory constraint. Like if you've seen what's happening with the memory chips right now, they are skyrocketing at record highs, trading at like 300% more than what they were last year because the world is memory constrained. Now, I think South Korea's stock market has just been taken over by 2 companies, SK Hynix and Samsung, because they manufacture memory for almost the entire world. I think like 3 memory companies have a near monopoly on the entire memory supply. 2 of them are in South Korea, and one of them is Micron in the US. And training requires 4 to 8 times more memory, and this is very expensive to deploy, very expensive to get, and, like, you can't just, dynamically add more memory because you realize, "Oh, we need more memory right now." You bake that into the chip, and you get what the chip comes with, and now we're starting to see chips that are dedicated for inference and chips that are dedicated for training, but this wasn't the case just a few years ago. This is a funny anecdote, but there were reports that Elon's XAI's GPU utilization stood at 11%. Or measly 11% compared to like the industry standard of like 40 or 50%. And even that isn't close to 100%. So yes, I think the existing hardware can be improved dramatically, but that doesn't sound trivial.
Yeah, I mean, like the problem with hardware is like you have to move like physical atoms, right? Like with software, you can just like take the existing hardware and just like get more out of it. So I feel like there should be more effort spent on. I mean, like both are important, right? Like, I mean, if you can't forget the software, you could get like better hardware, but like the software, there's a lot of room for improvement. Like there's a lot that could be done. Like, I wouldn't even be surprised, like, if in the future, like, the AI could figure out for us. Like, I could do, like, slash goal in Codex, and I said just like, "Hey, make this inference, like, 10,000 times faster," and then just keep on churning away until you get it. Maybe they'll figure it out. I think that's, like, something that somebody should try. Maybe I'll try, I don't know. I think that's not as far-fetched as it may seem. Anyways, uh, moving
So
on. Yeah.
So all of this inference talk was for running the next generation of models. Speaking of which, OpenAI has announced their next generation GPT 5.6, and it's a series of models. They have them in three flavors: Sol, Terra, and Luna. I think it's Latin for the sun, the earth, and the moon. The sun, Sol, is their flagship, biggest model, and it's on par with the Mythos and Fable 5 models. They're beating the Mythos 5 in certain benchmarks in Terminal Bench 2.1. Um, and yeah, this is exciting. I think compared to Fable 5 though, um, Anthropic decided to just release the model and then got shut down by the US government, as we found out a few weeks ago. But I think OpenAI decided to take a different approach where they went to the US government, tried to get feedback and approval to release it safely to people. And I think that's what we're waiting on. Um, Mark shared a poly market over and under here. I think we will probably see it by July 9th based on consumer sentiment here. What do you think about this, Nick?
Yes. So I have a lot of thoughts, and also I think it's amazing that we were able to go almost like an hour into the podcast, and before we actually talked about these new models, lots of things to talk about. But
I think LongCat
GB,
took up a lot of time.
yeah, GPT 5.6 is exciting. So
Especially for you.
yeah, I'm on the $200 plan for Codex. I've tried a lot of things, so like I'm really like refreshing my Codex almost daily looking for this 5.6 model. Because GPT 5.6 or GPT 5.5 right now, which is like, OpenAI's top of the line model, is really, really, really smart. And I think that, like, in a lot of ways, it's actually better than Anthropic's top of the line model because, sure, Fable is maybe smarter. However, Fable is ridiculously expensive. And, Anthropic's model is very good, but, like, they made it right now so, like, with Fable, you can only use it on their subscription plans, and you can only use, like, 50% of your daily limit, and it burns through tokens, like, really quickly, and
Ridiculous.
it's expensive. It's great, but it still makes a lot of mistakes, and also, like, there's this thing in the back of my mind with Fable is, like, is it, like, dumber than it was before? Because like, they say they're silently, regressing in, like, the outputs and, like, I remember when I tried Fable a month ago, from my memory, I remember, like, it was super smart and, like, very proactive. Like, I would ask Fable, like, a question, and it would say, like, "Hey, Mark, like, I did this thing, and I also noticed that, like, your dependency was out of date, so I took the liberty of upgrading that for you." It was amazing, and now it feels not as smart as it was before, but GPT 5.6 is, uh, going to be available. It's going to be maybe better than Fable, so it's gonna be potentially the best model in the world,
It does
and
seem more token efficient.
much more token efficient and cheaper. So, like with all those things together, like I'm very, very excited to use it. Because like GPT 5.5, I think what it's really been good at is long horizon tasks, meaning like you can set it at a goal and it can just work for like days. And it will like continue to work on that goal until it gets it. And I think that GPT 5.6 will be able to do the same thing, but like better and more efficiently. So uh like one thing that I did was for NovaCut, my video editing program. So if you are interested in editing video, NovaCut.ai, you can upload all your footage and the AI will edit it, the videos for you. But I had an issue where, um, so if you want to upload your footage to NovaCut, you need to be able to upload your footage to NovaCut, right? So like there was some issues where there was like if you had spotty Wi-Fi, sometimes the uploads would fail. So I ran into this issue here. So like we've been at my house here in Japan trying to get some more stable internet. And there's like an issue with some of the hard wires. So we're having somebody come tomorrow to look at it. So we've been on like wireless internet here. And one of the problems with wireless internet, as I find out, that oftentimes, like when it rains hard, the internet just like gets worse, right? Because like I guess like the internet signals are coming through the air. So then, like, if you have water come down, the water will like disrupt the signal, and then like the internet quality just becomes like, a little bit worse because it's not like through wires, but it's through the air, and then like the rain will block that. I guess it's called rain shear. So all of this was kind of new to me, and the internet became like almost unusable. So I was trying to upload actually our podcast to use like NovaCut so I could go and then edit the podcast on NovaCut. NovaCut can do podcasts. It's amazing. So like I had this 1 gigabyte file that I was trying to upload and it just like kept on failing. And because like the internet was just like it would go like the 50 megabits per second down to 0, down to like 2 kilobits per second, down to, up back up to 50, down to 0. Like it would stay off for like 3 minutes and then to go back up to like 3 megabits. So it was like very sporadic. And NovaCut was like, hey, look, it seems like your internet's not working, and it would just like abort the upload, and it was very annoying. So I said like, hey, ChatGPT, like I set like the /goal command. So like in Codex, so Codex is OpenAI's coding harness where you can use it like on your computer to go code. I said like, hey, take this like 1 gigabyte file and try to upload it like 10 times in a row to NovaCut. And anytime that it fails, make a note of the failure and then fix it. So it churned for about a day. And then it's like, it like would upload it and like, oh, this failed. Like, let me try again. And like, it kept on trying. And like Codex was good enough to handle the internet outages, and it kept on making changes to the code for almost like 24 hours until it was able to actually like upload it again and again and again and again. And it made like the upload way more resilient because like there isn't a lot of good ways to simulate bad internet, right? So like if you're in a developer tools in Chrome, like you can make the internet slower, but to actually simulate bad internet is actually like hard. I mean, like Shashank and I were talking about this before. Like there could literally be a company where all they do is just simulate spotty internet. And because a lot of developers, they are on like super fast Wi-Fi that's like, or maybe not even Wi-Fi, like sometimes like hardwired internet that's like very stable on their top of the line MacBook Pro. But like the actual user, they're going to be like using their internet like on a train, going through tunnels on their phone, and it's going to be like very spotty. And like you need to work on that, right? So it's like, I remember one of my first programming jobs, I used I think it was like a 2009 like Mac Mini. And like this was back in 2016 or 2017, and I was using like a 5 or 6 year old's computer, and it was like really slow. And I knew that like if I could go and then get like our website that I was like building at the time, like I knew if I could make it run fast on that Mac Mini, that I knew that it would be fast for anybody who's using like a more modern system. And I think that like oftentimes, like, as developers, we forget that, like, hey, like, not everybody's using, like, the latest and greatest MacBook Pro. People are using, like, the, second generation Fire tablets, and there's no shade on the Fire tablets. So it's a great tablet. Like, I worked on it for 4 years, so Fire tablets are great, but like, they're very cost efficient hardware, and there's new models coming out all the time, and then people might be on the first generation, so like that's kind of old hardware. So like it's going to be a little bit slower, and it's going to be used outside on like shoddy Wi-Fi. So like what's amazing is like you could say like, hey, given these constraints, OpenAI like set this goal and then just iterate on this until like you have it working. And it works the best when you can have a verifiable reward signal. So like if the AI can check its work and it can see like, oh, like, so in this case, with the upload, it could say like this uploaded or this didn't upload. This failed. So like the AI can say, oh, this failed. Let me keep on iterating until I can get it. And it can just like work for days until it finally is able to work and work efficiently. And it's really good for like refactoring and like making things faster. So like another thing I used the goal for was I said like, hey, this endpoint is too slow. Like this took like a second. I want you to be able to make the end-to-end response time of this API endpoint under like 200 milliseconds or under 50 milliseconds, and it'll just like keep on iterating until it does it. So there's a lot of like little things that we can do. So it's amazing that the AI can like hold context for that long. So yeah, you need to find verifiable ways to make sure that you do something. So this wouldn't be something you'd want to do for like design, right? Because like it's really hard to say like, oh, this design is objectively better than that design. Like that's kind of hard. It's like, oh, what shade of red should I have for like this button here? Like that it would be a little bit harder to have a goal. But like if you can have like a clear like failure case or like success case, then like that's the type of thing that you can use a goal for and like you can keep iterating on. And it's amazing what you can do with that. So it's like, if you have like a verifiable thing, you can just have this goal go for days and it'll solve it. It's like the coolest thing ever. And I'm so excited for GPT 5.6 to come out because I think that it'll be able to solve these goals better, more intelligently, more efficiently. So OpenAI, please release GPT 5.6 because I really, really want to use it.
Yeah, that was a really interesting insight. I think we're seeing people use these coding agents for longer and longer horizon tasks. And it's crazy that you've been able to use it for 24 hours to optimize something. Um, and this kind of begs the question, like, how do we measure these models today? Because I think the traditional sense of like capability, whether or not these models can solve or like what percentage they solve certain benchmarks, I think that matters less. And now we start thinking about, okay, what is the price point? What is the token efficiency? Um, so what I wanted to present next is CursorBench 3.1, which shows a benchmark for the average cost per task. So they have a certain task that they've determined that is worth solving, and they have shown on kind of a log chart the price performance graph. And you can see at the very bottom we have the lower capability models like Gemini Flash. We have some of the open source models, Kimi, we have GLM 5.2, and then as we go higher up, we get GPT 5.5, Opus 4.8, and at the way opposite end of the chart, um, topping the benchmark, but also at a significantly higher price point, is Fable. And the reason why Cursor made this benchmark is because they're trying to promote their Composer, which is creating a new frontier on this curve of price performance, and it's significantly cheaper at a reasonable performance. So I'm curious, have you thought about switching to Cursor at all? Because if you're spending a lot on optimizing things that take 24 hours, I wonder if this would make sense and if this would even be able to solve something like, okay, reduce latency of my API endpoint from 1 second to 50 milliseconds, or if that even did. Okay, first off, did GPT 5.5 solve it? And if so, how difficult was it? And do you think Composer would be able to solve that?
So the answer is GPT 5.5 didn't, well, so it did solve it, but not completely. I found that 50 milliseconds was impossible because I'm using a remote database. So just the actual time for like the network call to go from like my server to like the database and then back was about 200 milliseconds.
You should
So
co-locate. You should have everything
I,
in the same place.
I know I should, but I don't for some reasons. And I was actually like looking into that, but it seemed like a thing that wasn't worth it. It like the effort, like the juice wasn't worth the squeeze right now. However, I probably will be co-locating at some point. It's just like there's a long list, and I felt like, all right, let me just try to optimize what I can in software first, because I actually was able to get, to go back to the rant about like software versus hardware. Like, co-location is a hardware thing, right? It's like physically moving the servers closer together, right? That helps, like, to physically move them. But I was actually able to get like a 5x improvement, or actually more than a 5x improvement, by like optimizing the software first. So it's like, now it's like, all right, sure. I could go from like 200 milliseconds down to, like 10 milliseconds if I like co-located the hardware. But it's like the person who is actually using my system, they're probably not next to the my server anyways. So it's like, unless like I put like a CDN network, and then like I found
Yeah.
I can, it's possible to find like the closest hardware to them, and then like collate it, and then like duplicated the database to all of these like networks. And I wanted to spend all the money to try to like eke every last little bit of performance. I could be Netflix, but like
Wait,
no.
wait, where's your server right now? I assume in the
uh,
US? US West?
I'm using Hetzner. So like I have like some servers in like Oregon, and then I have some servers in Germany. Um, because like Hetzner, like the hosting provider, like my GPU server is in Germany right now, because like that's the only place that they like offer it. So yeah. Anyways, uh like it's okay. Like we don't always need millisecond latency, especially because like the LLM that like I'm sometimes using, like it will take like it'll take a while to respond anyways. So it's like
You could switch to Cerebrus. It's not bad.
uh well, I find like the actual like quality for like large contexts isn't quite there for some of the Cerebrus models, because
And they don't have
anyways,
the frontier models right now.
yeah, so like I'm using better models than what Cerebrus currently offers. However, I would use Cerebrus if it like made the use case, but I have my own benchmark. It is not there. So anyways, to get back to your original question, would I use Composer? Yeah, I mean, I'll try it. I think I was using like Composer 2, and it was pretty decent. And I switched to ChatGPT just because it was a little bit better. And right now, like I'll pay more for a little bit better, just because like my time is valuable, and I don't want to spend money on worse, if that makes sense, right? Like, because it's like if something is like 10% worse, and it makes like, more mistakes. And then I have to spend like another day or two, like going and cleaning up the mistakes that like I could have just avoided on the better model. I'll just pay for that. And like OpenAI with the $200 plan is giving me like a ton of compute. So like I'm pretty happy with it. Um, so I don't know. I'll try Composer. I think, and see how it does. I'm sure like Composer probably could optimize for some of these things, but I mean, OpenAI is just so smart that like I want to use it. But it's a good thing to like be working on these benchmarks. I don't know, to get the cost down, because it is cool to have like low cost stuff. That's amazing.
I feel like the takeaway I have from this is we need a model router. You don't need the top of the line best model all the time for every single task. And I'm sure a lot of the tasks that you're solving could be handled by Composer just as well. Especially because like a lot of these benchmarks are getting saturated at like 90 something percent. And so at that point, any of these models can solve it. You don't need to be burning credits with the best model, with the lowest latency, with the highest price. But here we are. I think I understand your tendency to err on the side of caution and just use the best model for every single thing. Um, Speaking of, there is another really good announcement from a Chinese company on this, uh, and it is Z Code. It's a coding harness from ZLM, and they have built a end-to-end solution rather than just having you use uh, their model directly from the API. They've built a coding harness, just like Claude Code, Open Code, Codex. Now you have Z Code, an open source alternative from ZAI. I'm curious, have you tried this yet?
Yeah, so I've downloaded it and I haven't used it just yet, but I'm going to. I plan on using it. I just haven't gotten around to it yet, because I have actually subscribed to the ZAI coding plan. But the problem is I used through all my credits. So I like at the time this was released, I didn't have available usage. Although I think it may have just reset
Reset.
within like the last day or something. So I need to maybe try it again. Um, but yeah, I think it's exciting that there are now more competition in the harness space, right? Because it's like, um, you know, having the LLM is not enough to do coding, right? Like you can go and you can like paste in like copy your code into the LLM and you can say like paste it and say like, hey, like how can I optimize this file, right? But like
Which
you
you were doing,
I,
I think,
I,
like last year.
I was doing that, right? So it's like I was doing my code and like I was saying like, hey, here's this file, here's this set of files, like let me copy this in and then like paste this into the LLM and then say like, hey, like how can I make this better? Like, what should I do here? And then I would like copy the result, paste into VS Code, and then it would go and then I'd be like, oh, here's this error that I got. And it was a very like laborious process. And I
But
know
but
some people
the funny thing was it was still better than GitHub Copilot at the time,
yeah.
but not as good as Cursor and Claude Code and some of the other competitors.
Right. So that's what I was doing. And then I realized like, hey, like you can get like a program that can do the copying and pasting for you. It can go and automatically like search through your files, write the code, make the commits, run the commands. It can do this for you. So everybody it seems to be making like a coding harness now, which can like help you avoiding the step of needing to copy and paste the code and have it help you write the code for you. So I think that it's great that we're getting more competition here. So I've been experimenting with a lot of these harnesses. Z Code
Eh,
came up
I'm
with
I'm
one. It's great. Yeah.
I've been looking, but I haven't found any good benchmarks that compare the actual harnesses. Because I would assume the harness with the model is going to perform differently than just the model by itself if you call it via an API. So
Yeah.
I haven't seen any of these coding benchmarks specifically mention the hardness, like Claude Code versus Codex.
So I found one actually. So artificial analysis, they have one where they are comparing the benchmarks, but I feel like it's not quite efficient. And I think that there is like room. So if somebody listening wants to go and then compare all of these harnesses, I think that would be amazing if you could like kind of go and compare like apples to apples on different tasks. So this one right here, I'm sharing my screen and I'm sharing the artificial analysis AI. So artificial analysis is a company or website that goes and compares every model to every other model, and they have a little bit of comparing like the same task based off of like a similar harness.
They have
So
the major harnesses. Yeah.
they have the major harnesses. They don't have GLM yet, I think. But they have, for example, they have the same task where they'll have, for example, um, if you have a task with Codex versus the exact same task with the cursor CLI. So, for example, they said like, "Oh, this task, we gave this our ranking of 71 of GPT 5.5 medium." But if you're using the cursor CLI, we're only giving it like 62. So it seems like the best harness for GPT 5.5 is Codex. So it's like OpenAI, they optimize their models for the Codex harness. So
The same thing with the Opus too. It performs worse in Cursor versus just with their own harness.
exactly. But the thing that like is not shown here, which I would like to know, is how does um something like Claude's model run on Codex? Because I know a lot of these like Chinese models, they can run on like Codex, and they can run on Claude Code, etc. So like I sometimes wonder like if you can kind of like mix and match, right? So it's like we say like,
I
oh,
don't think Codex allows that. I know Claude Code allows you to run any model through the CLI, but unfortunately, Codex doesn't.
oh, they don't. I thought you
So
could, but I haven't tried. So I don't know. But yeah, I think it'd be really cool if you can say like, hey, what's the best harness slash model combination?
I
Because
actually take that back. It says you can run other models with Codex.
okay, cool. I thought you could, but anyways, that's good to know. And like this isn't like doing a complete thing, but I would love to see kind of like all the combinations and like permutations, I guess, where like you say like, oh, like let's try this model with like all the harnesses, and then what's the best harness for this model? Because it's true that like when I'm using other harnesses, sometimes it feels smarter or dumber. Like I've been playing with have you heard of this like pi.dev harness? Um
No,
yeah, I've been playing
I
with
mean
that.
I've
So
heard of
like
it. I haven't played around with it yet.
yeah. So like a pi.dev is um a open source coding harness that you can use with any model. And it's cool because I feel like it's kind of like the Linux of coding harness. It's kind of like the Arch Linux of coding harness. So like Arch Linux is like an operating system that's like very bare bones. They just install exactly what you need. And pi.dev is like a coding harness where you can go and then install exactly what you need. So like it's kind of cool. It's like it's very fast, it's very bare bones. And then like the idea is you'll say like, "Oh, I'm going to go and then I was like I want some sort of feature." So I'll just have my AI build it, or I think they have like a plugin store where you can go and say like I want this particular thing, so I'm going to go build it. Because like one thing that I noticed is that like with Open Code and Codex and Claude Code is they have a lot of bloat. So it's like I don't use all the features that exist in a lot of these harnesses, and like it's fine. I mean, it's like it's minor, right? Like I don't need to use like 100% of things. Like it's okay, and I like to know that there's like more for me to learn, right? It's like, and then the fact that they're able to go and then create new things like slash goal in Codex or like slash loop, where you can like have these models run the same task repeatedly. Pi says like, hey, we're gonna go the complete opposite approach. We're gonna give you like basically nothing. We're gonna do the bare bones. It's gonna be really fast, and everything that you want, you can just go and then build that yourself. And actually, it's kind of cool because I've been using it, and it's much faster, and I'm able to build like a lot of custom tools just for like my particular workflows, and I can build exactly what I need, no more, no less. And yeah, I think that means I'm missing out on some features, but it feels like much more customized for me. So like, I don't know, it's kind of neat. I still like kind of fall back to Codex just because I'm on like the OpenAI plan, but for when I use DeepSeek or when I use GLM, I've been oftentimes using Pi, and it's been cool. I haven't done enough like hermetic tests to say like, oh, this is uh like specifically better than like open code or like Claude code or something like that. But I don't know. It's like it's exactly what you make it. So if you're like the type of person who really likes to fiddle, um, I'd recommend Pi.dev. If you just want like the Mac, where everything is set up for you, you should use one of the coding harnesses of the major companies. But if you like to tweak and fiddle and go and optimize every little last thing for like your use case, Pi.dev is probably the coding harness for you.
I'm gonna maybe recommend one more uh, customizable harness. So I've been following the terminal bench just to see who's at the top every once in a while, and it's always you know uh, a random name that I don't recognize. It's none of these frontier labs, and so it is AHE, which is an agentic harness engineering. So this is from a Chinese university, Fudan University, and what they do is they build the harness around your model dynamically. And what they do, they keep the model fixed. You just give it a model, let's say GPT 5.5, and they change the system prompts, the tool descriptions, the implementation, the skills, subagents, the memory, and then it keeps evolving and gets better. And it's open source. You can try it out. I'm curious to see if Mark, what your experience would be if you try it out. But right now, they're at the top of Terminal Bench. They're at 84.7% performance versus Codex CLI, which is 82. A few percentage points higher, but it's it's an interesting approach where they um I I I haven't looked deeply into their strategy, but I could imagine how they can have a certain task as a benchmark, and they keep evolving the system prompt, the skills, and all of the things that are you can modify until they get the desired outcome. Um, and yeah, that's another fully customizable agent harness.
That is really cool. I just tried to install it. I got some like Python errors, so I need to try to see if I can get this installed. I'll probably have AI
Ask
like try
Torres
to
to figure it out.
yeah. I'll probably have it try to install for me.
Yeah,
Uh, but you know, I think that is really cool, to be able to do this. But I guess like one thing about like continuing to switch in the harness is like it's a bit annoying to have to like reset everything up again because like
yeah,
it's not just using the model with the harness, but it's all like the integrations that you have. So like for example, uh in like Codex, I have a bunch of MCP tools where I'll have it where I can set it and I have like it set to like some of the Google Sheets where like I'll have and go and then I'll be able to write to Google Sheets for me. It can like save things from like Google Drive. I have it where it'll I have it like with my Google Ads account. It can like go and then like look at the ads, and it can like review my campaigns. I have some like web site stuff like Playwright where it can go and like do like browser stuff. I have like a bunch of like other things that I've configured. So um every time I install another hardware harness, I have to like go and then like reconfigure that. Which is not like a huge deal, but like it takes some time. So I kind of wish that there was, and maybe it exists. Like if somebody knows about it, please tell me. But like I would love to have like some sort of like universal config where I can say like, hey, these are all the things that I want, and then just like make it kind of like a universal standard where like I can go and then say like install a new harness and then point it to my universal config and then get it get access to like all the integrations that I already had, because it's not just enough to have the integration, but like it's also all of my like login, right? So it's like if I have to go and then um like give like reconnect my API key so I can go and then access my Google Sheets again. That's just like extra effort. And I'm sure there's a lot of like security implications to that, because like you don't necessarily just want any random software to have access to all of your data. But like if that could be done in like a secure way, I think that'd be really cool to have like some sort of like universal harness integration with all of your other software programs so you don't have to reinstall it, right? I mean, that's like kind of what Open Claude did is it like, hey, um, we're not any more special than any other harness, but like we're going to have a bunch of integrations already built for you so you could just like quickly and easily set that up. Like it'd be great if like they could optimize the harness and then also just like make it where you could optimize for all the things that you have set up. But again, I'm gonna try this harness because it might be really excellent. So that's a good call out. I'm gonna try it, and I'll let you know how it is. See if I can get it installed.
Yeah, let us know. Um, I think that's all I had on the list. We went through quite a bit. We talked about the major announcements. We do have some out there announcements from Meta if you wanted to talk about that.
Yeah. So this is one thing that I saw. I was just, kind of looking at my, you know, AI roundup, and I saw this crazy thing that Meta is working on. And like, I don't know if crazy is the right word, but um, it is a brain to QWERTY. So I guess what Meta is trying to do right now is they are um trying to be able to like read your thoughts, and then you could think to type. So I guess it's kind of like Neuralink, but this is non-invasive. Uh so I guess like it can go read your brain waves, and then it could go and then control a mouse and a key board. And this is actually like the second iteration, and I guess they've traded on a lot more training data. And I think I forget exactly where it was, but um my understanding is that you have to uh it's like non-invasive, but you need a lot of hardware to actually like read it from you. So like I found this like picture here where I guess like what they need to do is they have this like specialized chair that it can go and then like read your brain. It's like this thing is huge. So for like the audio listeners, um imagine like a lazy boy, but like above like the head is like this massive scanner. And it's almost like this. It's like this huge piece of equipment, probably like 3 or 4 times like the size of like a random human that you have to like sit into your chair. It's kind of like they call it like a meg scanner. I don't know anything about a meg scanner, but that's what it is. And it can like read your brain waves, and then like you can think and then type. Um, I don't know. That's like out there, but I guess like Facebook, they're spending their billions of dollars and they're doing some cool stuff. So this is, I think, very much in the prototype stage, but man, that is futuristic. Like, I mean, just to be able to think to type, that is amazing. Shashank, I don't know, what do you think about this?
Yeah, I think the obvious comparison is Neuralink, which is significantly more invasive. They shove tens of thousands of electrodes into your brain to detect with high fidelity what kind of electrical impulses your neurons are firing. But this is a low fidelity, but enough to guess what you're thinking and turn it into characters. They did mention the resolution isn't very good. I think they mentioned something like 61% or something like that accuracy. And I don't know if you need to um, think each character like uh, GENAIMEETUP, or you just think Gen AI made up and boom, it's there. How does it handle typos and all of that? So that's I the productionization of this thing is a big question mark, but it's really cool research. I think Meta has always been doing really cool research. They've built a lot of image recognition stuff. I think maybe like this is along the same lines. They're detecting like similar images or digital signal processing and converting that into data, into segmented into structured information. They built a lot of image recognition. They built image segmentation, video segmentation, and I think this is like the continuation of that work. And I'm really happy Meta's still doing research, despite a lot of people leaving. Some of the top um, godfathers of AI leaving, and them having a lot of attrition and shakeups all around, and finding their footing again to figure out how they can contribute in the LM space. But it's cool that they're still pushing the frontier of AI in other areas.
Yeah, I mean, this is amazing. I mean, that's all I had. Oh, Shashank, did you want to also talk about the Anthropic Science as well?
Yeah, we can end with this one. I think this is like the holy grail of AI. This is what a lot of the research labs, a lot of the heads of the research labs are excited by. This is what drives them. The hope that, they can just wake up one day and say, "Hey, AI, just solve quantum mechanics, figure out string theory if it's still a thing, solve nuclear fusion, and it'll just do it." We're not there yet, but this is a harness for scientists. So right now, scientists in most fields have to deal with a bunch of different fragmented ecosystems. They work with PubMed, Jupyter, R, a different terminal, and they have multiple steps, and they have to aggregate all this information from different sources, copy paste things, upload Excel sheets. So Claude has been or Anthropic has been taking over lots of different verticals, and science is the most recent one of these, where it's built a harness that consolidates all of these different sources and gives scientists over 60 curated skills connectors um, that are pre-configured for um, medicine or biology more broadly, including genomics, single cell proteomics, which is like the study of roto-organisms. Don't quote me on that. Structural biology, uh, cheminformatics, and a lot more. So the hope, which I think is that this is gonna be a quad code for scientists to be able to stop copy pasting things into ChatGPT and use a harness to significantly speed up their work. Have Claude work on very long horizon tasks with all these different sources of data connected, and hopefully produce something useful without as much um, of the bottleneck as we have today with humans copy pasting things. So yeah,
This
this
is
is
so
exciting.
exciting. This
Yeah.
is so freaking exciting. I, I I don't know enough about biology to comment one way or the other, but So if anybody's listening and they're like an expert in genomics, let us know what you think about this. Cause like, from as a layman who doesn't know a lot about like
I
biology, I
would
mean,
say I would say if you're any kind of a researcher, maybe let us know how much time you spend copy pasting things across different portals, and if a harness like this would save you a significant amount of time, where it would just handle all of these different data sets, all of these different connectors, and free up some of your time by getting context about your entire project. Because I don't think they specifically focus on medical models per se, but connecting all these different sources, kind of like a Claude Code, which has access to your repo, to all the different MCP servers about your database or other APIs that you're using. So yeah, hopefully this is a productivity unlock for scientists.
hopefully, yeah, I don't know. But it's exciting because let's get that longevity escape velocity. Anyways, that's all we had. Yeah, so if you made it this far, that means you like what we're doing. So please, if you haven't subscribed yet, please do so. Like the video on YouTube if you're watching on YouTube. Leave a comment, ask us any questions that you want. But really, we're trying to grow this thing. So what would be amazing, like my specific ask to you is go, if you're listening to this on a podcast platform, please leave a review, and ideally, if you made it this far, a 5-star review. And leave a comment. Say that you listen, that you like it. It would mean a lot to us. Like, we don't have that many reviews, so like if you could go and leave one, that would be absolutely amazing. So please, like, we don't make any money off of this. We do this like just because we like talking about AI. But like we really would like to grow this. So please, um, help us, help you. Like if you can help us grow this, we'll be able to get like better interviews, more people, more better podcasts. So yes, please leave a review and help us grow this thing. That would be absolutely amazing. Also, one more thing is uh this is brought to you by NovaCut. So NovaCut is a video editor that I am working on, that can take all of your footage and edit the video for you. It allows you to work at a higher level of abstraction where you don't need to know a detailed thing like video editor. You don't need to learn Premiere Pro. You can just talk to the AI and have it edit the video for you. It's amazing. I use it for editing these podcasts. I use it for making travel vlogs. I use it like very, very heavily, and it's getting better all the time. Try it out, novacut.ai, NOVACUT.ai. Try it out. Would love to know what you think. Actively working on it daily. That is my full-time thing right now. So I left Amazon Big Tech so I could work on it. It's very exciting. That's all we have. Help us, help you. Leave a review. Really, seriously, thank you so much for listening. We love you. Again, thank you, thank you, thank you for listening, because I know that your time is valuable and you decided to spend it with us. So again, that means the world. We don't take that a privilege lightly. Again, we'll see you in the next one. Appreciate again. Bye for now.